Finding the probability that involves at least one means finding the probability of getting at least one or more of an event. So when they say at least one, we just mean one or more. Now, if it's a small sample size, then it could be easy to find the probability involving at least one, because we can just count them up and be done. But if your sample size is large or it's unknown, it can be a little bit too cumbersome to do that. That's why it's easier to rely on finding out what you do not need and then use the complement rule to find out what you do need. So take out what you don't need and then use the complement rule to get what you do need, and you have your probability. But let's see that in action, because that sounds a little bit weird. A couple is planning on having 3 children. Assuming an equal chance of having either a boy or a girl for each birth, find the probability that the couple will have at least one girl among the 3 children. So we can try and find out how many different ways you can have 3 children, boy, girl, boy, and so on. Could take some time, you could miss one, or we can just find out what we don't need and then do the complement rule to find out what we do need. So we want at least one girl among 3 children. Well, that's easy enough. You have a girl, 2 boys, 2 girls and a boy, all girls, but there's different combinations. But we can actually just find out what we don't need. The one thing we don't need is all boys, which means we don't want to have a boy, and a boy. That's the one thing we were trying to avoid for our question. So how do we find the probability of having all boys? Well, we know we're going to have either a boy or a girl. There's only 2 outcomes for each birth. So 2. And they're going to have 3 children. That's what they're planning on having. So we can say it's 2 to the 3rd, which will give us 8. So here there are 8 total outcomes. Now, what's each one? I don't know, but it doesn't really matter because I know there are 8 total outcomes. So I know the possibility of having all boys, there's only one way to have it. All 3 are boys. So the probability of all boys is 1 out of 8. Now that's what we don't want. What we want is at least one girl. So we're going to do the complement rule. So we're going to say the probability of at least one girl is just a complement of the probability of all boys. So 1 minus 1/8. Just put that in, and we're going to get 7/8. So the probability of getting at least one girl is 7/8. So using the complement rule here is a little bit easier in trying to find out all the possibilities. We could have gone straight from the total number of outcomes, but this is just a small example to see how it works. Now let's see a little bit more of a complicated one. You are taking a 4-question multiple choice test. Each question has 5 possible answers, and there is only one correct answer per question. What is the probability of getting at least one question correct? So again, this is what we're looking for, at least one question correct. So we can use the complement rule, and we can find out the one thing we don't want, which is finding none of them correct. So again, we need to find out some probabilities. So probability of all wrong, which is the one thing we don't want. Now we got to go and see how we can find out some numbers. Well, we know that there is 5 possible answers and only one correct answer per question. So we're given A, B, C, D, E. Well, only one of those can be correct, which means 4 are incorrect. So 4 out of 5 are wrong. So our probability, and I'm going to use decimals this time, is we have an 80% or 0.80% chance of getting a question wrong any given time. And we have 4 questions on this multiple choice test. So we can say it's 0.80 raised to the 4th. So 0.80 for each one to give us all wrong answers. And that will end up giving us 0.4096. So the probability of getting them all wrong is 0.4096. Now we can use the complement rule to find the probability of at least one correct. So again, just like with before, we're going to do 1 minus what we don't want. So 1 minus 0.4096. And when we do that, we're going to get 0.5904. So using the complement rule, kind of going around a little bit, the probability of getting at least one question correct is 0.5904.